planning department, and I'm gonna briefly outline the plan behind this project. And we are standing here down at the harbor front, which is behind us. And this is the tunnel that you're gonna see the construction site of. It's the Kalvebod Cloudburst tunnel project. And in normal operation, wastewater is from this area. It's being treated at the Lynetten wastewater treatment plant. That's where you're going after this visit. And it's the biggest plant of wastewater treatment in Denmark. And the catchment is here. We have another treatment plant over here in Damuså. And from the municipality of Frederiksberg, which is within Copenhagen municipality, water during normal operation flows down to where we are now. And then along the harbor to Langebro, and then from Zealand to the island of Amager, to a big pumping station called Kløvermarken, and then it's pumped up to the treatment plant.
To split up into contracts. There's a civil contract, which is the intake here and the entire tunnel. The tunnel have a severe length of 1.3 kilometers, and then we're having the pumping station here. The water will come with gravity, and we have to lift it up in the harbor from the pumping station. The critical part were decided to be the design and supply of pumps, so that's why it has been separated in two different contracts, and Grundfos were awarded for the design and supply of pumps here. And that's actually what I will tell you a little bit about. The cut drawing is looking like this. It is what you see here. You have the lake, you have the intake, and you have the 1.3 kilometer tunnel, and then you have the pumping station here. It's a really big pumping station. It's the biggest pumping station in Scandinavia. It has a diameter of 17 meter and a depth of 24 meter. And we're having 6 propeller pump, really big ones, close to 8 ton a piece, 500 kilowatt each. Each of them can move 5.5 cubic meter a second. So this is 6 pieces, totally 30 cubic meter a second. This is really severe amount we're talking about here. It has been an atypical project because it is estimated only to run 1 hour per 5 years. So the question have been, how can we ensure the highest possible availability? How can we ensure that the technology will function when we need it for especially that hour? So the tender material were based on a CFD simulation from Jacobs in London, and we have made huge number of iterations based on Jacobs start point. And we have changed the design and optimized the design severely within the pumping station. That was one thing. Another thing were when the gates from the tunnel were open, how could we take out the energy of the water? And that was also a quite special challenge. Thirdly, how can we ensure that we will distribute the water equally to all 6 pumps? And how can we avoid to get big vortex problems? How can we have a equal distribution? So we have simulated on the CFD simulations, and finally, when we couldn't improve it further, then Danish Hydraulic Institute built up a 1 to 10 model and tested it. And that was such an accurate model that we in principle could modulate and create all possible scenarios with water level, pressure, distribution, amount of sewage, different combination of water. And the model finally validated that the design functioned. Secondly, on the electrical side, O4 have decided to have as simple design as possible. So no frequent changer, no soft starter, pure copper directly to 6 pieces of 500 kilowatt engines. And to ensure power supply, it is connected to 2 different power plants with a separate cabling route, so you are not depending on other connections. We have modulated all the electrical connections that transformer, dividing stations, etc. can take the forces when you are pushing the start button in milliseconds until all 6 pumps are up in normal revolutions. So that was the hydraulic. It was validation of the electrical part, and then we also had a lot of validation of the forces of when you are installing the propeller pumps. They are installed in 14-meter long canister pipes. So to ensure that those pipes can obtain the enormous forces when you're starting a 500 kilowatt engine directly. So yes, there has been a physical supply of 6 pumps, but the most important part of our delivery has actually been to validate and ensure O4 that this pumping station will work when they need it.
Thank you.
Yeah, I think that's actually it. I have some press release you can have if you are interested.
Perhaps I can just add one point. Bygge mentioned it briefly.
Out of the concrete, so it's making a lot of noise, and the whole machine is vibrating when it's working, and it's a lot of wear. So they have their own blacksmith workshop here, so they change the teeth and everything, and they weld on it all day long. Come tomorrow, you're allowed to. Where all the fancy restaurants and where the young people can go out and have a good time. We are very close to people's places where they live, so yeah, we have to take that into account when we do our work. Here we have excavated to the bottom of the shaft, so you can go down if you want, but be careful, there's rebar reinforcement on the bottom, so you have to be careful you don't trip. There's like a viewing section where you can look down. It's about 18 meters deep, so if you just follow Tove, you can just now? Yeah, let's go. Probably gonna get it right on the fingers.
No.
Okay. Close to the top. Ja, altså jeg har haft rigtig mange på det her projekt. Det er også fordi det ligger så centralt. hier vorgehalten.